Hello, this is to introduce the spreadsheet tutorial called Sunpeg. You're looking at a Cartesian projection of the sky dome. So it's like a flattened map of the sphere of the Earth. This is a flattened projection, a vertical projection of the sun path. So in these coordinates here, Cartesian representations of angles, 0 is south, 90 is east, plus 90 is west, and 180 in either direction is north. The y-axis is degrees above the horizon. So we've taken the sky dome, we've flattened it out into a vertical projection of the sun. So the shortest day of the year, December sunrise, solar noon. The sun is always directly true south at solar noon because it's halfway through the sky. And then sunset. December, then this line is for January, February, March, April, May, June, the longest day of the year with the highest sun. July, August, September, back to the equinox. October, November, back to the summer solstice in December. If we trace the obstructions in the sky from buildings or trees or anything that occludes our view of the sky dome, we see that in this example, and this is a building out there, I'll show you how to put these points in, that for December, these are half-hour increments, so 1 o'clock, 1:30, 2 o'clock, 2:30. After about 2:30, this particular building or obstruction blocks my December afternoon sun. So to enter the coordinates of all of these obstructions, we just want to do each corner, right? And we'll let the spreadsheet draw a straight line from point to point to point to point. We input those, input screen, by naming our city and the correct latitude. Don't worry about the Sunpeg height, that's another feature of this spreadsheet we'll discuss later. And we put ourselves at 0, 0, 0. You can experiment by moving this around later, but putting ourselves at 0, 0, 0, we find the first obstruction, start at the ground. Where is it north or south of me in feet? These could be meters as long as you use consistent measure, but let's say feet. North or south, so this is north of me, it's negative 100, and it is west of me, positive 100, and it's 1 foot higher than my 0, 0, 0 starting reference point. So we're looking at shading on this one point on the ground. This does not represent a window, it represents a spot. Then we simply enter all of those. The spreadsheet calculates it into the angles we need to plot on the shading mask, and the obstructions all appear here where you can interpret it relative to the sun position for any particular month and time of the day. Thank you.